I wanted to put it up on the projector thing, but it doesn't seem to work. Anyway. So, yes, we were talking about dates. So, how is time stored in a computer, right? So, I'd like to go off slide a little bit because some interesting stuff sort of popped up for me in a course, the other course that I'm teaching this semester, which I think might be of interest to you guys, if you're interested in knowing how computers store time. Way back, in the distant past of the year 1970, or slightly after the 70s, the Unix operating system was developed. The Unix operating system became the basis for pretty much every major operating system after that system, right? Pretty much, like, Unix did everything so well, pretty much everything is based on it, right? It invented stuff like the hierarchical file folder structure and other assorted things. So, this thing is on, right? Just very mildly, okay. So, the time standard that was used in the original Unix implementation, which is the one that has stuck, is known as Unix epoch time, right? So, essentially, Unix epoch time is stored as an integer. It's an integer that would be stored inside of your computer system somewhere, even if it's Windows. It counts the number of seconds that have elapsed since January 1st, 1970, the beginning of time. All right? So, this is an interesting, it presents interesting problems because this decision was made, in excess of 50 years ago. And most likely, the people who invented Unix at that time did not have any conception that we would still be using Unix epoch time as one of the major ways in which time is recorded on this planet. Does anybody remember the Y2K problem? A few of us in this room might be old enough to remember Y2K. Most of you youngins are too young for that. Some of you, it may have happened when you were but wee babes, or mere twinkles in your father's eyes. So, the year 2000 bug/problem was an issue where we weren't sure what the behavior of computer systems was going to be because they had been designed such that the year 2000 was not representable in some of them, right? So, basically, lots and lots of people worked out this problem in advance of the year 2000, and everything was fine in the end. People thought that it was going to be the end of the world. People thought planes were going to fall out of the sky. People thought people were going to lose all the money in their bank accounts. All kinds of stuff was going to happen because of Y2K. And I remember very fondly from my youth, because I was but a wee ankle biter at the time. I was 12 years old, and I remember going into Staples and buying, you used to buy video games on compact discs in a Staples. That's how you got video games for your computer, right? And some of them had printed on the jewel case Y2K compatible. And it was hilarious because it's not a software problem, it's an operating system problem. It's bran flakes now with extra bran. It was just like low-fat bran flakes type advertising and marketing, and it was so funny. But anyway, so why am I telling you about all this? Well, it turns out that this is going to happen again, folks. In the year 2038, we run out of time in 32-bit representations of Unix epoch time. because it's counting the number of seconds since 1970, January 1st, 1970, eventually, I think it's like in March, some day in March of the year 2038, we're going to run out of space for computers that use 32-bit representations for that, right? Now, this isn't necessarily this isn't a huge problem for modern computer systems because we have long since adopted 64-bit operating systems, right? The problem really comes down to embedded devices, right? Things like your wristwatches and anything that stores time, right? Because it's hardware, the more bits you put into something, the more expensive it is. So a lot of these hardware manufacturers are still using 32-bit registers to store Unix epoch time in their real-time clock modules, which means that when that magical date in the year 2038 hits, you're going to have rollover and wraparound. Basically, that integer is going to flip negative, and we're going to jump that distance from January 1st, 1970 to that date. We're going to jump that back into the past, which puts you in the year 1901, sometime in the summer, I think. So in that 1 second, you will be in the year 2038, and the next second you will be in the year 1901. And that is going to happen to a bunch of devices, and it's not fixable with software patches. So that's the beauty, that's the beautiful thing about the Unix epoch bug. Y2K was easy to fix because it was primarily a software problem. The Unix epoch bug is, in a lot of cases, a hardware bug. It's in the frigging circuits. There's no amount of software patching that can remove and add hardware, right? Because it's hardware, right? So, eventually, all of your devices that are of a certain age are just going to blow up, like that.
What? They just won't function anymore, or will the time be so negative?
The time will jump to 1901, and who knows what effect that's going to have. It depends on what the system's doing with the clock, right?
I understand.
Right? You can imagine, if a bank were vulnerable to this, and you had, say, about, 140 years of negative interest applied to your savings account in 1 second, that might be a problem, right?
I understand. Okay.
I assume that the banks are aware of this problem, but yeah, so that's just an interesting little thing. I think you can make a pretty good case that really you can measure the advancement of human civilization pretty well by the advancement of timekeeping technology specifically. So anyway, incidentally, adding one more bit to that 32-bit register doubles the amount of time that you can keep, so it pushes that date, a further nearly 100 years into the future. And if you use 64 bits to represent Unix epoch time, you can put dates out into the year 150 million or 150,000 or something like that, something very, very long that we probably, if humanity manages to survive the next decade, we might, or next 100 years anyway, we might get that far, but we'll see. We'll see. But anyway, so that's the Unix epoch bug. It's going to be a tricky one. Hopefully all of your electronics that you care about, you throw out in the next 16 years. So, and replace them with ones that aren't vulnerable to this bug. But anyway, so, inside of the context of a regular computing device, that is to say a laptop or some such, how do we get Python specifically to represent to us these dates, right? So we have the datetime library in Python. This is fairly easy to understand if you already have a good grasp of classes and objects in general. The datetime object is an object containing fields for both date and time, right? It contains fields for year, month, day, in the case of the date half, and hours, minutes, seconds, microseconds, or milliseconds in the time half, right? So yeah, somewhere inside of this, it's using Unix epoch time in the background to translate all of these values, right? All of this is being like it's not storing year as year. It's storing it in Unix epoch time. So, you know, so it goes. So just like floats, there may be some kind of theoretical upper limit of the dates that can be represented with this. But it's not, you know, it's not something that we particularly care about. So we've got datetime.date, that just stores year, month, day. We have datetime.time, which stores hours, minutes, seconds, and microseconds, and possibly time zones. We have datetime.datetime, which is the union of both this and that functionality. So it stores both a date and a time. And we also have a time delta class. So time delta is useful because it allows you to represent the difference between 2 points in time, right? Without this, we kind of have this problem of how do you represent, you know, 5 minutes according to like absolute time, right? It's like, you know, do you say, you know, the year 0, the month 0, the day 0, 5 minutes, right? That's not a valid date. It doesn't really make sense. So we have a separate class specifically for representing differences or distances between points in time. Does that make sense? So if you perform a subtraction operation on time objects, you will get a time delta object as your return value. Right? Make sense? Should do. It's time. Everybody should be reasonably familiar with time. Considering we're all you know, fundamentally bound by it. So, in terms of actual Python code, from datetime import datetime. So this line allows us to access the datetime object inside of the datetime library without having to do datetime.datetime, which is kind of stupid, right? So we have a now function, which basically just looks up the system clock and returns to you whatever the current value of time in your computer system clock is, right? We have, we can do this example. Let's do this as an example. Concrete. So from datetime import datetime now is equal to datetime.now. Test2 is equal to datetime 2022, 4th month, 2nd day, 9th hour, 0th minute, 0th second. Yeah. Time left is equal to test2 minus now. 9 on the left is. So there you go. It's a time delta. You have 58,261 seconds remaining until the midterm starts, which is kind of cool. How are you all feeling about the midterm, by the way? No?
No, not
No?
Not good right now.
You don't get a vote. You don't get a vote.
You wrote it.
Parts of it. Yeah. Any questions about the midterm before we move on? People always have questions about the midterm. Yes, sir.
What are the hardest concepts that we covered on this?
Depends on what you're good at. I mean, I can tell you the coverage of the midterm is everything up to and including CSV files. So whichever part of that you found hardest, that'll be the hardest question on the midterm. Yep, object-oriented programming is, yep. Question?
Include option of topic 9, right?
No, not quite to the end of it. We're not going to be covering JSON or YAML. We're not doing either of those on the test.
Okay, but you have some beginning of it.
Well, the CSV stuff, that's fair game, right? Comma separated value is fair game. JSON, we're not gonna test you on or anything past that point.
And plain text file I/O is also, like file reading and writing is also fair game.
Oh, well, yeah, that comes before CSV.
Yeah.
So, yeah. Yeah, just like general reading and writing in plain text files, that is definitely fair game. In fact, I would say you can probably very much expect a question about file I/O in some manner on the test. I think that's a fair statement. Any other questions about the test? No? Okay. Everybody's going to get 100% done? 80 is good. 80 is like, if you get an 80, then you're meeting expectations. So, I know high schools have like poisoned everybody's mind with their ridiculous grade inflations, so that people think that 80 is a bad mark somehow, but 80 is not a bad mark. Okay? 53 is a bad mark. 80 is not a bad mark.
Sir, why 53?
Yeah. Why? I don't know. It's like slightly above pass. It's like you just passed. I don't consider just passing to be a good grade. But that's my personal subjective position. If I got a 53, I would say either I hate this course or I want to study harder at this course. So, for me, that was thermodynamics. I hated that course. That course hated me. So, anyway. So, we took some pains in the previous lecture to note all of the different formats which time can have throughout the world. Some people like to put things first, other people like to put the same things last, etc., etc. And the Americans are doing something completely unpredictable as usual. The datetime object obviously is going large to small in terms of the arguments provided, but what if you have to read dates that were written by an American? My God. There's a function for that. So the strf time method is interpreted string format time, right? This is for outputting time in a particular fashion. Paired with this, we have a sister function, strp time, string parse time, which allows us to read a string in given a particular format. This is a little bit cruel to do to you guys because you have not studied C yet. This is the manner in which C does string formatting. So So string formatting then. It's really easiest if I just explain to you like how printf in C works. So let me just give me one moment. I'll pull up a different course that may have been. Let's see here. Introduction to C. That should do. No. What? No. Stop. There we go. So. Oh, is this is not introduction to C programming, is it? Okay. Okay, not quite. We need the next one. Basic constructs, that'll do. So, let me just get a good example here. There we go. All right. So I know that this isn't a class on C programming, but Python is a C-based language, and certain things that it does are actually directly derived from C, including the manner in which it's using these format tags inside of strings. So we might as well go directly to the source. This is what a C program looks like. I won't dwell too much on it, but everything inside of this main function is the stuff that executes when you execute the program, right? The equivalent in C of Python's print function is printf, or print string, print format. Printf is your print function, right? So you've got printing stuff where you're not trying to output anything, like the value of a variable. That's just regular strings, right? In C, you have to include a new line character at the end because it doesn't put that in for you, but that doesn't, that's kind of immaterial. This is the line that I'd like to call your attention to. So the first argument of this is the string, but it has a special character in it. $D. $D says, I am leaving a hole in this string, which I expect an integer to fill, right? Then, any further arguments to the printf function are used to fill the hole. So in this particular instance, we have two integers, right? I1 and I2. We have those being entered by the user at the command prompt, right? So I1 and I2 both acquire values from scanf, which is like C's version of input. We then add the two of those together. The value of this gets put in this position in the string. This is string formatting. String formatting is actually a we have a whole topic on it, more or less, when I teach a C course, because you can do so much with it. Pardon me. So the important thing to know about this character here, lowercase d, specifically represents integers. If it's float, it's f. If it's scientific notation, it's e or g, right? If it's a pointer, it's p, right? The character indicates what that field is filled with, right? So, flipping now back to the course that we are taking. When you provide this format string, that is exactly what every one of these character groupings %sign something. That's what all of them are doing, right? This one, yeah, I'll take a guess what that inserts. Year. Very good. So, in addition to just the numerical values, you can also have it tell you what day of the week it is in like text. which is kind of cool, right? You can have month names instead of month numbers. You can have month abbreviations as well. There's a very large number of these guys that you can pull out, right? But what it does is it takes this format string, inserts into it the appropriate data as collected from the datetime object upon which that method is being called. Does that make sense? Any questions about that? See, this is why I think that everybody should learn C as their first language. Because, like, you're going to have to learn it anyway. So that's how you produce a printout of your time according to any format that you please. These dash characters could be anything, right? The colon characters, this is of your choice, right? For example, today is blah, today is blah, right? So, in contrast, the string parse time method takes as its first argument the string that you are parsing, right? This is the string that you are that you have received from some external source. For example, if you have timestamps inside of a file and you've loaded those files in from a CSV file or something using file IO, if you wanted to extract a bunch of datetime objects for that, you would sequentially call string parse time and provide the string that represents the date. In addition to this, you also need a format string that tells us how this string has been formatted. So, B abbreviated month day, abbreviated month name, pardon me, D is day again, year is year again. Notice the inclusion of the comma. If you don't have all of the non-date characters represented in the format string, then you'll have a parsing error, right? It'll say, I can't read this, this is in a format I don't understand, right? So all of the space characters and colon characters and comma characters must be in the precise location that they are in the string you're trying to read, or else it just won't work. Does that make sense? It's a little bit strict, but then again, this is programming, and you should be used to the computer being more strict than you're comfortable with by now. So, good. Any questions about that before we move on? Good.
Sorry.
Oh, sorry, question.
Final exam covers until which topic?
I mean, the final exam will cover, yeah, pretty much. Well, we'll see. We'll see what it'll cover.
I mean, it will cover topic 11 as well, or?
I will answer that question closer to the exam. You should worry about the test first, because the test is a lot more immediate. So, time zones are a pain in the butt in general, but they're particularly a pain in the butt when you're connected to the World Wide Web, and anybody you could be communicating with might be from any given time zone on the planet, including the weird ones like Newfoundland that are only a half hour removed from the adjacent ones. Python datetime objects can have a time zone set for them. It is then possible to convert between one time zone and another. I won't require this of you, but it's still good information to have. So, the recommended approach for development in general, not just in this class, keep all Python datetime objects in UTC time. This is to say with no time zone offset, right? UTC time is the same as Greenwich Mean Time, which is the time in Greenwich, England, for, you know, because they were very concerned with time in that town, I guess. So yeah, keep it in UTC time, convert it to whatever you need, wherever you need it, right? It's easiest to use an external package such as PyTimeZone to help with time zones. It's a lot of work to reproduce time zones, so like just use a library. Like try to think about time zones as little as possible, because it's an abyss that if you stare into it long enough, the abyss will stare back into you. So UTC, by the way, stands for Universal Coordinated Time. So this is an example of time zone conversion. We import both datetime and pi time zone. We set up a time zone as Canada Eastern, which is Eastern Standard Time. It basically reads in a whole bunch of these strings and gives you various time zones as a result. We have before we have a particular date, our before time, with time zone info equal to UTC time, right? We have a time delta of 1 second. We have an after time. We add the before time to the time delta. We have a format string, right? We print before and after as time zone TZ, right? Where TZ is Canada Eastern. So this as time zone method in the middle converts us from UTC time into whatever the local time zone is that has been specified above, and then you can apply all of your familiar methods to it however you may wish. Does that make sense? Good. All right, and I'm just going to skip that slide. Who cares? I'm the prof, I can do that. So, any questions? Good. Moving right along now. So I said I was going to skip visualization and jump right to databases. We'll come back to visualization if we have time, but normally I have to cut machine learning short, and I imagine a lot of you are more interested in machine learning than something you could do easily with Excel. So we'll do that. So, but first, we shall talk about databases. So, does anybody know what a database is? That's kind of a dumb question. A little bit. So, if you want to get technical, a database is like pretty much any place that you store data, right? Anything can be used as a database. But when we talk about databases, like in the modern internet age, what we're typically talking about is some kind of remote server which you would be able to log into, send data to it, request data from it, in some way interact with that server in a manner that's controlled and maintains the integrity of the data inside of the database. This is a very important problem, right? Hypothetical example, right? Let's say you have a large social media company. You're the proprietor of this, right? You have, say, maybe 3 or 4 billion users. Not all of whom are human, right? Not all users are human beings. Important to note. But let's say you have 3 billion users of your service, right? If 2 users, make a request at the exact same time, which can happen, how do you service those requests? right? The database handles it. Databases, like, if two requests come in at the exact same time and you were to try to service both of them at the same time, they may conflict with each other, right? Inside of databases, we maintain a property known as atomicity, right? So, does anybody know what the word atom means?
Very small.
Not quite, actually.
Isn't it derived from like the Greek word the smallest thing?
Yeah, it's indivisible is what atom means, right? It's the smallest thing which is indivisible. But we're not really we're not concerned with atomicity meaning small. We're concerned with it meaning indivisible. When a transaction occurs on a database, that database locks itself into that particular transaction until it has terminated, and only then will it go on to the next one. This is known as the principle of atomicity. It is by maintaining that property that no two requests will occur at the same time, conflict with each other, and cause inconsistent data state, right? Which is generally what you want to avoid. So, we're going to talk about SQL, which stands for Structured Query Language. Was it something I said? So, databases are like programming languages. They allow us to process and store data. However, data is stored in dedicated files and loaded as needed. The data can be much larger than the available memory, and there is no need to explicitly open files and read data, right? When you access a database, it is assumed that you want to open the database, perform a transaction, then close it. So the open and close operations are not built into the operations themselves, they are sort of implicit in the structure of the thing. Data can be accessed simultaneously, quote unquote, because nothing can actually happen simultaneously, by clients or users, either locally or remotely. Data is atomically updated. Data is either stored or not, but never becomes corrupt, even in the case of failure, disk error, or network disconnection. So even if the current transaction fails, the database remains in a stable state. This is databases are constructed for data reliability. That is their main focus, right? Complex queries can be written in a dedicated query language. So SQL, Structured Query Language, is a different language than Python. Some people, at a low level, you shouldn't necessarily think of it as a programming language per se. It's more like writing statements without the control flow. That's a bit more the flavor of it. That being said, SQL can be expanded into a full programming language. Like you can pipeline the results of some queries into others. You can set up if statements. You can set up loops in it. We're not going to deal with any of that. We're just going to focus on making queries specifically in this class, because this is not a databasing class, and I just want to give you a flavor for it, right? But question?
What exactly is
A query. Best analogy in Python is a line of code. So it's a command. We're going to see it. Let me just show you quickly some queries. So each one of these is an SQL query, right? All of these queries are requesting to view data inside of the database. We'll get there when we get there. But this is what SQL looks like. Good. So in relational databases are kind of an outdated model a little bit for databasing. I mean, there's new stuff that's on the market, which a lot of people prefer, especially, you know, the younger they are, the more the more likely they are to prefer the new technology. You know, old fogies such as myself are probably still using a fair amount of the old style, because that's just how life goes. So, relational databases are an older model of databasing, but there's so much use of it, it's so ubiquitous that it's still very, very much a relevant thing to learn, despite the fact that, you know, it's not new or trendy. For example, most websites that will store like passwords, you know, you log in with a username and password. Ever wonder how the usernames and passwords are stored? Relational database in a lot of
plain
cases.
text.
Eh?
In plain text.
In plain text, yes, indeed. They don't even encrypt them. Why would they encrypt the usernames and passwords? Yes. Yeah, oh, by the way, encrypted databases are definitely a thing that exists as well. Bank records will be stored in relational databases, right? A very large amount of the internet, the information floating around the internet will be in relational databases specifically, right? It's useful. So, how is it organized? Roughly speaking, very roughly speaking, it's organized approximately the same as an Excel spreadsheet file, right? In an Excel spreadsheet, you have several sheets, right? Sheets, the tabs along the bottom. You can have access to several different spreadsheets at once. Inside of a spreadsheet, you have columns and you have rows, right? When you're talking in relational databases, sheets are tables, rows are entries, and columns are fields. That's the terminology. So, like if you use spreadsheets as kind of like your mental model for how this works, it's not bad. It's not bad. Although it's, you know, it has its own eccentricities. So, let's have an example scenario. Let's say we wish to create a database for running a video rental store. We need to keep track of, number one, the movies that we have available to rent. Number two, our list of customers who rent movies. Number three, a list of which customers have rented which movies. 3 tables. Movies, customers, and rentals. The purpose of the rentals table is to relate entries in the movies table to entries in the customers table. That is to say, the rentals table is a relation from movies to customers or vice versa. That is why it's called relational databases, right? Relational in the discrete math sense, as in you have 2 sets and a relation maps from one set to the other. So, here's some example data of movies. We shall produce that at length, you know, probably next week. I just want to say one more thing before we go. One more learning thing, right? I know that all you Python programmers are not used to declaring your types up front, but in databasing, declaring your types is something that you need to do, just like a bunch of other programming languages. So, when you are creating a table, you must know what type each field will have. The available types inside of most SQL distributions: integer, real, text, Boolean, and date, stored as a numeric value. It turns out actually that I don't really have, I'll get into this next week, but basically SQL was written to a standard, and then a bunch of companies made their own implementations of SQL and added their own special features to it. That's why you see a million different SQL clients, right? Each one has a slightly different feature set, so each one will have slightly valid types that you can have in the database. They're all basically functionally equivalent, but it's an excuse to have, some companies prefer one thing, another company will prefer another. If you know how to program in SQL in general, in one of them, you pretty much know how to program in any of them. You just need to learn what specific features are available in the particular SQL client that you're using, or the SQL, like the software itself. But we're going to get into the distinction of all of that next week. Thank you very much for your time and attention, folks.